I think with pure traditional machine learning approaches, we end up with a lot of C minus stuff, which is why a lot of AI initiatives fail at enterprise scale.
Partially too, we stick with those approaches because they're easy to measure. It's
Yes.
kind of like the metric becoming the goal kind of problem.
Yeah, no, I mean, measure things, do things that are easy to measure because they're easy to measure, right? And report on a dashboard to an executive or whatever.
For a long time, I think the thing is that like we were so bad at these problems, and that even sort of a basic framing like that felt so far off that we performed decently on it that it sort of didn't matter. I think, right, is that we maybe always realize, all right, this isn't the best way of testing, but like we're just trying to learn, anything at all. Right. Let's get to that C minus when everything is giving us, 20 and 30%. But then I think the problem is, when you start to see things, get C minuses and then Bs, then it's like, oh, wow, actually they're getting As, but we're still kind of taking the same approach. You then start to realize, okay, wait a minute. Okay. If we actually want to get someone to that very high level of understanding, this is not the way to do it. And if someone manages to get there incidentally through this method of teaching, maybe we're actually more concerned than excited.
Yeah, maybe the problem was just really easy and we shouldn't have spent all this time trying to solve it, right?
Yeah, well, I mean, we're definitely finding that. I think that's one of the things that's tough is these algorithms get smarter and smarter, and a lot of the basic tests that and granted, like even 5 years ago, it used to be that you could spend 20 minutes, label some data, and create something that trivially would stump the best AI on the planet, right? Or like it would at least struggle really significantly to learn that problem. That's just not the case anymore. And it does really mean that we've got to be way more intentional about these problems and these constructions than we ever have been before.
Yeah, but it raises uncomfortable questions too. Like if I'm just measuring F1 score or whatever my proxy for accuracy is, and it's just the machine learning interface, there's no question of like, did we do a good job teaching this machine, right? And that auditing that is tough. It gets back to the point you were making, Brandi, about like there are 300 different processes. No one wants that light shined on them and said like, hey, you did this different from your neighbor in the next desk. Like, why? Why is our model bad? I think it's your fault.
Yeah, well, and I think like what we were seeing early on, right, like is like it's like a one-time solve, right? So like meaning like something goes to production or like it's in test or dev and it never moves to production because it's a one-time solve, and then you really start questioning like how do you actually operationalize this thing, right? Because like that's great that you were able to do that, like data team, right? But we've got this whole group of like SMEs that like needs to be able to operationalize it because it's not good enough on its own. It comes back to the earlier point, right? Like neither is good on their own. And what we were seeing like was you can't operationalize it. Like it's kind of on its own. How do you create downstream processes and how do you enable like the best, like what I'm going to call workflow between like human and machine?
Yeah, that's the problem, right? That's the thing that we're here to figure out and solve.